Hi all. In this session, let's learn about basic process concepts. As a part of introduction, let's start with understanding the basic concepts of process. Operating system executes a process in two ways. The first comes batch system. Here, jobs are collected and executed one after the other without direct user interaction. The next comes time sharing system. Here, multiple users can interact with the system at same time. The CPU shares its time among different user programs and gives each process a small time slice. Now let's see what is a process. A process is a program in execution. It must be progressed sequentially, which means it is executed step by step. The current activity is represented by a program counter value, which points the next instruction to be executed. Next, processor register content, which stores the temporary data needed by the CPU. Now, let's understand the difference between program and a process. A program is a passive entity. It is just a file containing the instructions stored on the disk. Process is an active entity. It is a program that has been loaded into the memory and currently executing. It has its own program counter, CPU register, memory, and other resources. In simple terms, when a program is loaded into memory and start its execution, it becomes a process. Now let's understand the components of a process. It is also called as process memory layout. Whenever a program is loaded into memory, it is divided into four main sections, namely test section, data section, heap section, stack section. The first section is text section. It stores executable program code and its size remains fixed during the execution. The next is data section. It stores global and static variables and it is also having the fixed size. The next is heap section. It is used for dynamic memory allocations, such as memory allocation using malloc in C programming. The heap always grows upwards whenever it requests for more memory. The fourth section is stack section. It stores the temporary data such as function parameters, function return address, and local variable. It always grows downward as the functions are called. We have to notice that the heap grows upwards and stack grows downward. The operating system must ensure that they do not overlap each other. Now let's see what happens during a function call. When a function is called, its parameter, local variable, and return address are pushed into a stack. When a function finishes its execution, these values are popped from stack and the memory is released automatically. So the process memory layout helps the operating system organizing memory efficiently during the program execution. Now let's see how a C program actually lives inside the memory. So each part of the memory layout, that is text, data, heap, and stack, maps directly to a section of our code. In this code, we can notice that after the header files, int x and int y is equivalent to 15 is given. So here, the variable int x is stored in uninitialized data section, which we have in our memory layout. And int y is equivalent to 15 is stored in the initialized data section. The next instruction is invoking the main function. The functions like main, print, and malloc always resides in text segment. The parameters argc, argv are stored at the top of memory along with the program arguments. A separate section is provided for argc and argv parameter, which is passed to the main function. Inside the main function, we have int star values. That is, here value is a pointer variable. It receives the address of an integer variable. The next comes int I. Here we declare the variable I as integer data type. In main function, we have values and I, which is the local variables. It is always stored in stack. The next instruction is values is equivalent to int of malloc size of int 5. It uses malloc and dynamically allocates memory for 5 integer values. Malloc returns the starting address of allocated memory which is stored in the pointer values. When malloc is called, it creates a space for 5 integers in heap memory space. So hope you are clear about this process management layout with this example C program.
Thank you all.